Okay, in today's video, we're going to go over a subscriber question. So the question is how to implement windowing functions without actually using a windowing function. So specifically, the question here is sometimes in data engineers interviews with FANG companies, they ask you how to do Windows functions without actually using the window function. So I'm hoping they're asking this because it's not available, as opposed to having it available and not trying to use it, because I've really questioned the logic behind not using functionality that's available to us. But anyway, so how do we write a SQL query that gives me the same results as lead, lag, row number, etc., without actually using the window functions? So let's take a look. So I've got a query here that's just going to a table that is collecting information about file size of a particular data file in a database over time. So each day, we're just collecting the file size and the space used. So what I'm trying to do here in the lag is to get the previous days. So that's what lag allows us to do. And we talked about that in the other video. So in this case, we've got space used on the 8th is 2496. And as you can see, when you go to the 7th, we get the lag value was 2496. And then this value keeps matching the one from the previous row. What that allows you to do is like calculations and direct comparisons in row. All right. So we all know what these partition functions allow us to do. The question was, how do I do this if I don't have these available? Or how do I do it without using the analytic functions? And the answer is use a correlated subquery, which is what we've got here. So I've got the select, and then I'm going and getting the top row, and it's getting its space used in megabytes from the DB file time series. Then I have to do a join back to the other result set on the key, which in this case, join keys, database name, and file ID. And then so I get the one that's just before. I have to get where the capture date is just after the capture date of the current row. And then I have to make sure I have this order by ascending. And this allows me to get the previous row. And I'll run it again here. And as you can see, we've got the same answer. So that's how you're able to do this without having the analytic functions. And once again, I wouldn't recommend not doing this if the functionality is available. I'm going to show you something here. I've got another video out there where I talked about set statistics IO on. And what that does is tell you exactly how much IO that the database is performing in order to execute your query. So if I look at the query using the analytic function, I go to the messages, you can see here that logical reads is only 47 from the table. Okay, and now I'm going to do it with the correlated subquery version. So again, look, 47. We're going to go to the messages. The logical reads is 94 from the table, but it also has to create a work table. And look at the number of logical reads. This is orders of magnitude worse in terms of performance. And another way you could have written this is basically writing code where you have a cursor that goes through every row and holds the last value so you can do the comparison. And that's actually on the order of the performance of the analytic function that you've got here. As you can see, that's only using 47 logical reads. There was another question I found in the comments of one of the videos asking about Ola Hellegren, the index optimization job, and why is it filling up log space? And I figured I'd just cover that real quick here. So whenever you're doing index maintenance, you're basically changing data in the database. And in order for SQL Server or any database to guarantee consistency after your transactions are committed, it will have to write to the transaction log. That's where all the information goes until the commit is done. And then it will start writing those pages out to the actual index structures and data structures after the transaction has been committed. And to make matters worse, whenever you're doing index maintenance, especially when you're doing index rebuilds in SQL Server, the whole thing is done in one transaction. So however big your table is and however big your index is, let's say it's the gigabyte, That's how much transaction log space you're going to need to complete that operation. So that's why it's filling up your log space. That's it for today's video. Thanks for watching. I appreciate the questions. And yes, just to reiterate, whenever you're trying anything new, make sure you're doing it in a non-production environment. So I hope that the trend log space didn't fill up in your prod server for that when you were doing the index maintenance. But you need to do your experimentation in an environment where you can test and evaluate what's going on. So that's just one quick tip for everyone. I hope you liked the video. Please like it, subscribe, comment, keep those questions coming. Talk to you later, guys.